Hey everyone, I just wanted to put together a quick video on how to calculate spindle speeds and feed rate. So when we go ahead and actually start programming, this becomes a little bit more important to us because we don't really have manual control over this. So we have to tell the machine how fast we want our part, or our cutter, to cut through our part. And that's going to depend on a few variables. It's going to depend on the type of tooling that we're using. It's going to depend on the material that we're cutting, steel, aluminum, plastic, what have you. And it's going to depend on how fast the cutter itself is spinning. So what we're going to do is we're going to review how to calculate spindle speed and how to calculate our feed rate, how fast that cutter actually moves itself linearly through the part. So there are a few starting conditions that we need to take into account here. So the main thing we have to determine is what our tool is made out of and what our cutting material is made out of, whether it's steel or aluminum. So our formula for spindle speed is going to be 12 times the surface speed, we'll talk about that down here in just a second, divided by pi times the diameter of the cutting bit. Now, when we use this, we simplify this. Pi is about 3, so we can do 12 divided by 3 and simplify this equation to 4 times V divided by D. And that's the equation we're going to use pretty much throughout the rest of the semester. So let's go ahead and calculate our spindle speed that we need for a high-speed steel cutter cutting through aluminum. And we're going to assume that we're using our standard 2-flute, half-inch diameter cutter, the one that we usually use on the mills. So if we go ahead and look at our equation here, our cutter is going to be 4 times V. So 4 times V, V is our surface speed. We're going to use high-speed steel tooling in aluminum, so our surface speed is 300 surface feet per minute. And we're going to divide that by D, our diameter, which is ½ inch. That's going to give us a spindle speed of 2,400 RPM. Now, in the lab, we're used to cutting closer to 16 to 1800. We do that in CAD/CAM and in 1000 for safety. If a part gets chucked out of a lathe, it's a lot safer to have it do it when that spindle's spinning a little bit slower. So that's the reason why we have a discrepancy here. When we start cutting in CAM, we're going to be using the full spindle speed. So we're going to be cutting as close to the full spindle speed as we can. This is going to give us a more efficient cut, and it's going to give us a better surface finish, but more importantly, it's going to allow us to ramp up our feed rate. That's how fast the cutter is moving linearly through the part. Because it's actually quite significant, the time savings that we'll run into using a higher RPM. So we're going to assume 2,400 RPM as our spindle speed. Now let's calculate our feed rate. Our feed rate in inches per minute is calculated by the feed rate of inch per tooth, we'll talk about that in a second, times the RPM that we just calculated, times the number of teeth that we have. So our inches per tooth, this is how far each tooth is moving into the material per cut. This is going to vary largely by tool type. A lot of the manufacturers of tools will specify what the inches per tooth is. Most of our tooling is set for 0.002 inches per teeth, or inches per tooth. So what we're going to do is we're going to take our feed rate of 0.002, multiply that by 2,400 RPM, and then our ½ inch end mills have 2 teeth. So we're going to multiply all those together, and that's going to give us a feed rate of 9.6 inches per minute. that's going to be our sort of theoretical maximum. We can push it a little bit faster than that if we alter our depth of cut. Our depth of cut is typically 10% of the diameter of the tool, with the exception of face mills, but those are the exception. So for our 1/2 inch cutter, we're cutting 50 thousandths max depth. If we're using a 1/4 inch end mill, something a little bit smaller, our max depth is going to be 25 thousandths. So we're going to be cutting at 9.6. We're going to round that up for calculations and for when we do programming to 10 inches per minute. Typically, it's pretty safe to round it up to the nearest whole number, and that's what we're going to be doing in our case. But I just wanted to cover this with you guys, just a quick refresher. If you guys have any questions on this, let me know. And as always, have a nice day.